Hey everyone, welcome to the first tutorial on the Procedural SkyBox plugin. Procedural SkyBox is a library of advanced noise shaders that let you create an infinite variety of customizable and realistic skyboxes with clouds and nebula. In this video, we will cover how to get started with the plugin, explore the different preset materials and noise shaders, and understand how the various noise parameters are working with each other to create the perfect looking skybox for your fictional space environment. We will also cover colorization using parameters and color curve, the concept of physical lighting to achieve the most realistic lighting to our skybox, and using multiple layered materials for additional depth and complexity in your skybox. So let's get started. Alright, so let's first look into the different types of assets present inside the plugins content folder. So the material itself is very simple because all of the main functionalities are inside the material layers. This is our main material, layered procedural sky. It just has a single node, the material attribute layers node. I have created a separate tutorials on material layers that you can check out from the link given in the description. Now let's look into the material layers. So far I have only added 3 different types of layers, each representing a type of noise shader, namely Simplex Noise, Musgrave Noise and Perlin-Worley Noise. When you look into the shader folder inside the plugin, you will find more types of noise shaders as well. Once you get the understanding of how these noise shaders are being used to create the material layers, you will be able to create the additional layers yourself. Let's look into the preset folder inside the material instances folder. Here you will find lots of preset material instances in folders corresponding to the respective noise layers. To quickly implement this, check out the skybox I have here. Just select any preset and add it over here. Before you start customizing these preset materials, I would suggest you to make a duplicate material. This way you won't be losing the original preset material, which is part of the plugin's content. If I update the material presets later, your customized versions won't get overwritten in that case. Before I start modifying the material instance, let me make a copy of it so that I don't end up overwriting an existing preset material. Currently, the material itself does not have any parameter. All the parameters are in the material layers. You will need to customize these parameters inside the layer parameters tab instead. Every layer present in this material instance will have its own set of parameters. And of course, as already mentioned before, you can add as many layers as you would like. Alright, so we are now going to understand more about this parameter so that it's much easier for you to know what you're changing before you can just blindly experiment with this. This particular layer is of Perlin-Worley noise. So there are certain parameters which are specific to this particular noise type, but the majority of the parameters you're seeing over here are common across different types of noise shaders. The parameters specific to Perlin-Worley you can see inside the noise advanced category. Currently we only have a few parameters specific to changing the cell size and influence, as you can see over here. These are some generic noise parameters. The first 3 parameters are responsible for adjusting the contrast of the noise. And then you have the inverse noise, which is basically applying 1 minus to the noise output. And the seed parameter is going to randomize the noise. Now let's look into the noise layer parameters. By using noise layers, you can create more detailed and natural looking patterns. Let's explore and understand the parameters that you see over here. The amplitude controls the intensity of the noise. Higher amplitudes make the features more pronounced. The frequency controls the scale of the noise pattern. The frequency scale is responsible for multiplying the frequency with each octave. The octave parameter is typically not adjusted because increasing the octave slightly reduces performance. Significant changes are noticeable up to 8 octaves. Beyond that, the differences are minimal. So it doesn't make much of a sense to set the value beyond 8. The gradient scale basically changes the amplitude per iteration of the octave, and usually having the gradient scale between -2 and +2 works for me, but I have found that depending on how the other parameters are set, gradient scale can actually give a very different result. So it's better if we explore these more when we do more and more examples on different types of noise shaders. Next, we have lacunarity and persistence. These two parameters function similarly to the frequency scale and gradient scale respectively, but here they are working within the colored octave layer instead of the primary octave. Two different noise layers we maintain. One is the primary octave layer, which determines the shape of the noise layer, and the second is the colored octave layer, which colorizes the noise across multiple iterations, where lacunarity and persistence change the frequency and amplitude per iteration of the color octave. Here you have remap mean and remap max to remap the current noise between the mean and max values. And these smooth step parameters are actually responsible for smoothing out the colors. We here need to understand how the colors have been set up. There are multiple ways to set the colorization of the clouds, and the most basic one is blending between these three parameters: the darker color and the mid color and the lighter color. And how these parameters are blending among each other are determined by these smooth step values. And now here we have the color remap min and color remap max. These two basically remaps the range of the color value. So if part of your skybox is too dark, then you can adjust the darkness by changing the color remap mean. Similarly, you can adjust the brightness by changing the color remap max. Now let's adjust the smooth step values so that the darker color is also visible as well. Apart from these parameters, you can also set a custom color curve for even finer controls of how you want to colorize your skybox. When increasing the color curve blend, it increases the prominence of the color curve effect. The color curve override parameter will override the existing color curve settings. So by setting the override closer to 0 and increasing the color curve blend, you can achieve a color output that utilizes both the color curve and the default colorization. Now let's play along with the parameters a bit more till we get some satisfactory results, and you can also get an idea of how the parameters are working together. Okay, so this was an example of Berlin-Wally noise shader. Now let's look into Musgrave noise shader. I'm still working on creating good quality presets out of the Musgrave shaders. But here is one preset that I really liked because its shape is similar to cloud. So let's open the material instance. Most of the parameters here are going to be similar to what we already saw before, but there are certain parameters specific to the Musgrave noise, and we are going to focus on those first before we modify the parameters. Let me save a child out of it because I don't want to modify this particular material instance, and hopefully you will also avoid directly modifying the preset material instances inside your plugin content folder. Okay, in the noise advanced category, we'll find the parameters that determine the core structure of the Musgrave noise. Here you can add some turbulence on top of your existing noise layer, and the work parameters allow you to create a distorted look for your noise shader. And here you have several shape parameters which further adjust the shape of your Musgrave noise. And of course, on top of these parameters, you also have the common parameters that we had already discussed. So let's tweak the parameters further and experiment with the variations that I can achieve with this particular material instance. Before we move on to our next noise shader category, which is Simplex, let us understand how physical lighting works in our skybox. The physical lighting model is used to simulate how clouds react with the atmospheric lighting, and this enables creation of highly realistic lighting effects for your skybox. By adjusting the parameters such as anisotropy, denser cloud ratio, cloud absorption, and cloud shadow strength, you can fine tune the cloud lighting to achieve the desired result. If you want to tone down the effect of the physical lighting, you can simply lower the value of the physical lighting blend parameter. The cloud absorption parameter determines how much light is being absorbed by the clouds, and increasing that is going to darken your clouds. While the shadow strength parameter adjusts the intensity of the shadows within the clouds. Here, clouds anisotropy controls the directionality of light scattering, making clouds appear brighter when viewed against the sun. The denser clouds ratio parameter influences the thickness of the clouds. The parameter light direction offset controls the direction of your sunlight. So if you want to make this in sync with the direction vector of your sunlight source, then you can definitely do that by adjusting these parameters directly from blueprints. Here you can set the light color. You can also adjust the ambient color. This parameter basically adds a brightness to your overall skybox. Of course, on top of this, you can also modify the further colorization of your skybox by changing all of these parameters as we have already explored before. Now that you understand how physical lighting works, creating a perfectly lit atmospheric effect for your skybox will be much easier. Alright, so let's now explore the simplex noise. The structure of simplex noise can resemble cellular patterns, which is why it is more suitable to create the varied textures pattern found in space nebula rather than clouds. So what you're seeing right now over here is an example of simplex noise shader where multiple layers of noises have been applied in order to give you this kind of complex look. We are going to explore the multi-layered simplex noise materials in a bit, but for now let's look into one of the basic examples of simplex shader. Of course, most of the parameters you already have seen, but some of them are specific to simplex noise, like these parameters in the advanced category. Now let's play with the values a bit further. Alright, so now let's look into another simplex noise material over here, and let's continue tweaking the parameters till we get something visually appealing out of it. Okay, so this looks really satisfactory, at least compared to what it was before I started to modify the parameters. Now we are going to look into the multi-layered materials as you can see over here. So these materials are combination of multiple simplex materials laid on top of each other, and this is totally giving me the feel of being inside a fictional space environment. So let's now customize one of the multi-layered materials. Okay, this material does not look as complex as the ones we just saw, and this can be a really good starting point to demonstrate and showcase how the multiple material layers are working to give you the kind of quality that we have just seen. Currently, this material instances has two layers. You can add more layer by clicking on this plus icon over here. Each layer has its own set of material parameters. And you also have the blend asset over here, which is simply adding these two layers. This is also a kind of material function that can have its own material parameters as well. And this is your bottom layer. You can change the layer asset over here and see how it looks with different noise settings. Alright, so now let's begin customizing this material instance. Multiple material layers also has this additional advantage of having separate light sources in different areas of the skybox, as you can see over here. Let's spend some time now tweaking the parameters further. Apart from all these individual parameters corresponding to each of the layer instances, it is also possible to have common parameters that work for all of the layers. As an example, I added this parameter global tiling that adds a uniform tiling across all the layers in this instance. The way I did this was by adding a scalar parameter as part of the material attributes, because our material layer asset can only accept function input of the type material attributes, otherwise it throws a compile error. You can only pass all your common parameters through this attribute node itself, and of course the choices you get is still going to be many because of the many nodes and possibilities that you get with this, but this is still kind of a limitation of the material layers. Alright, so that's it for this tutorial. I hope you find it helpful, and in the upcoming tutorials we will cover creating custom materials that make use of the noise shader library and help you achieve even further customizations on your skybox. Thanks for watching, and I will see you in the next video.